Okay, I'm going to start Chapter 9 now. Chapter 9 will be the last chapter that we'll be doing for the course, and we are only going to cover 9.1, 9.2, and 9.4. 9.1 and 9.2 are all about polar coordinates, and so we'll get started with that. So far we've been graphing points, x, y, in what's called the rectangular coordinate system, or the Cartesian coordinate system we sometimes call it. In this section we're going to introduce a new coordinate system which we call the polar coordinate system. Definition: any point in a plane can be identified by its distance r from a fixed point and its angle of inclination theta. This type of coordinate system is called the polar coordinate system. The fixed point that I'm talking about in the wording here is sometimes called the pole, and the initial ray is called the polar axis. So I've got a picture of, okay, here's the pole, or the origin, and the polar axis, and you're going to go out some distance on the polar axis of r units, and then you're going to rotate that point either clockwise or counterclockwise about the pole to put that in a certain spot. Point P is going to have coordinates r theta, and just like in rectangular coordinates, the order matters. Okay, it's got to be in the order r theta, not theta r. In this example, I'm going to have us just get some practice plotting points in the coordinate system. Now, before I do that, attached, actually I'm not sure if I attached this, but I've got some polar graph paper here. If anyone would like this, just why don't you send me an email and I can send you a blank sheet here. So I'm going to be plotting points on the polar grid. Now, of course, I'm not going to draw an entire polar grid, but let me just refer back to this sheet after we've done a few problems here. So like if I want to plot the point r 7 pi over 6, I need to begin at the pole, and I need to go 1 unit out on the polar axis, and then I need to rotate that point counterclockwise by 7 pi over 6 radians. Like we've done before, a positive angle means that you're going counterclockwise, a negative angle means that you're going clockwise. Okay, now on the, so here'd be my point then in quadrant 3, which would be my answer then. Okay, now on this graph, here's like the 7 pi over 6 radial line, and I would just simply go 1 unit out on that radial line and plot that point right there. Okay. Here's another point, 2, 3 pi. Okay, so if we begin by going 2 units out on the polar axis, and then we rotate that, 1 complete revolution around the pole is 2 pi radians. If I go at another half revolution, then I would be on the 3 pi axis. So I want to be going 2 units out on the 3 pi axis. Now that point, 2, 3 pi, would also have the same coordinates as the point 2 pi, right? The 3 pi axis is the same as the pi axis. So that's one observation here. In polar coordinates, you can describe a point many different ways. We'll see that, just depending on how many revolutions that you take around the pole, or if you use another axis, you can sometimes have a negative r value. We'll see that here in part D. Here's part C. Okay, so I want to plot the point 2, negative pi over 4. Well, I'll go, here's the negative pi over 4 axis. The negative pi over 4 axis would also be the same axis as the 7 pi over 4 axis. Okay, it's just I was going in a clockwise direction, not a counterclockwise direction. And basically I want to be going 2 units out on the negative pi over 4 axis. Okay, now this point right here, 2 negative pi over 4, that would be at the same spot as 2 7 pi over 4. Okay, and again, that's what I was talking about before. These you can represent a point several different ways in the polar coordinate system. Part D, we want to plot the point negative 2 pi over 4. Okay, so here's the pi over 4 radial line in quadrant 1. Now a negative r value means that you're going in the opposite direction that many units. So I want to be going, here's the pi over 4 axis. I want to be going in the opposite direction 2 units, And so that's going to mean that point will be located in quadrant 3. Here's negative 2 pi over 4. Negative 2 pi over 4, that would be located at the same point as 2, 5 pi over 4. Okay, if I were to have, a positive r value there. Okay, so here's the connection between polar coordinates and rectangular coordinates. Of course, in rectangular coordinates, I've got the x and y axes. One big difference with polar coordinates compared to rectangular coordinates is that in rectangular coordinates, you have the x and y axes. In polar coordinates, you've got infinitely many axes, all kind of shooting out from the pole there. Okay. Now, we've got our major axes, and then we've got our minor axes. I was commenting on major angles and minor angles back when we were doing like Chapter 6 and Chapter 7. So that terminology is coming into play here also. We've got our major axes and our minor axes. But obviously, one big difference is that I've got infinitely many radial lines all shooting out from the pole, whereas in rectangular coordinates, I've only got the x-axis and the y-axis. Okay, so suppose that we're going to plot a point, P, starting at the pole. If I go x units to the right and y units up, then point P would have coordinates x, y. That's one way that you can plot point P. Another way that you can plot point P is you can go out r units from the pole, and then you can rotate that point clockwise or counterclockwise. And so here I'm going to go counterclockwise and put it into quadrant 1. Okay, so point P can also be represented as r theta, whatever angle of inclination theta happens to be there. Now we're going to have to know how to convert from polar system to rectangular system, and then also from the rectangular system to the polar system. Here's our conversion formulas for being able to do that. Cosine, and so in this triangle here that I built, r would be the radius of a circle that I would make, is another way to look at this. Of course I got a right triangle here, and cosine of theta would be adjacent over hypotenuse. If you were to multiply both sides by r, then x would be equal to r cosine theta. So in polar form, you're going to know r and theta. R cosine theta would give you the x coordinate. Sine theta is opposite over hypotenuse, y over r. If you multiply both sides by r, then y would be equal to r sine theta. And again, if you know r and theta, you can then be able to find y. How about what if you are in rectangular form and you want to go to polar form? Well, in rectangular form, you're going to know x and y, and we need to identify r and theta. So to get r, of course, I got a right triangle, and that means that I can apply the Pythagorean theorem. X squared plus y squared equal r squared. Okay. So again, I know x and y. I'll be able to get r by using the Pythagorean theorem there. To get theta, well, I know x and y. With theta, y is the opposite side, x is the adjacent side. Opposite over adjacent is how we calculate tan theta, right? So tan theta is y over x. If these two values are known, and then I can take tangent inverse of both sides, then I can get the value of theta there. Okay, so these would be the conversion formulas that we would need, allowing us to go from one system to the other system. Let's get some practice converting between the systems. So suppose that I have a point in polar form. I've got two examples here, and I want us to convert the point to rectangular coordinates. So I'm going to have to know x and y. Now, when you do this, of course, one of the things that you'd want to pay attention to is where the point is located. And of course, when we use our conversion formulas, we're going to want that point to be located in exactly the same spot, okay, or the same quadrant. So if I were to plot the point 4 pi over 6 on the polar grid, here's the pi over 6 axis, and I would go out 4 units there. And here'd be that point, which is in quadrant 1. So when I go to rewrite this point in rectangular form, of course I want to make sure that I'm still in quadrant 1. R is 4, theta is pi over 6. Okay, so to get x, I need to compute r cosine theta, or 4 cosine pi over 6. Cosine pi over 6 would be root 3 over 2. You're working with a 30-degree angle there. And a 30, 60, 90 right triangle. 4 over 2 is 2, so 2 root 3 would be the exact number for x. And then to get the y coordinate, we need to compute r sine theta. R is 4, theta is pi over 6. Sine pi over 6 is 1/2. 4 times 1/2 is 2. Okay, now this point looks correct. Of course, it is correct. Okay, but both x and y are positive. That's what we want, if we're going to be in quadrant 1. So 2 root 3, 2 would be my answer there now in rectangular coordinates. Here's another one. Okay, so -4 and negative pi over 4, that is in polar form. I need to rewrite that into rectangular form. Now, the negative pi over 4 axis would be right here. I'm going clockwise. And r is negative, so I need to be going in the opposite direction 4 units. And that's going to put me into quadrant 2. So I need to make sure that when I get my answer here, I'm in quadrant 2. If I'm in any other quadrant, of course, that's a wrong answer. So let's calculate x. R cosine theta. R is -4. Theta is negative pi over 4. Cosine negative pi over 4 would mean I'd have a triangle in quadrant 4. The adjacent side would be 1, and the hypotenuse would be root 2. So -4 times 1 over root 2, if you rationalize the denominator, you would get -2 root 2. Now, I like that x is negative here because, if I'm going to be in quadrant 2, of course, I'll want to be going to the left of the origin. X has to be a negative. Let's get y. So r sine theta, -4 times sine of negative pi over 4. Now, again, the negative pi over 4 axis is in quadrant 4, so I'd be working with a 45, 45, 90 triangle in quadrant 4. The opposite side is -1. The hypotenuse is root 2. And, okay, if you take -4 times -1 over root 2, that would be 4 over root 2. Rationalize the denominator, and you'll have 2 root 2. So -2 root 2, 2 root 2, that would be in quadrant 2. And this point here would be my answer now in rectangular form. Okay, let's take a look at going from rectangular form to polar form now. Okay, and I've got 2 examples there. So suppose that x is 1, y is -1. I need to use my conversion formulas, these 2 here, to go to polar form. Okay, so I'm doing that. R squared would be 1 squared plus -1 squared, or 1 plus 1 is 2. Okay, take the square root of both sides, so r would be plus or minus root 2. I'm going to choose r to be positive. You'll see why. I did that later. It would be okay if r is a negative. You're just going to make sure that your answer is going to be a point that would be in quadrant 4 here. So let's just take r to be root 2. I got to get theta. Tan theta is y over x. So -1 over 1 is -1. And okay, what angle are we talking about there? Well, if the opposite side is -1 and the adjacent side is 1, then that would mean that you're in quadrant 4 and you're talking about an angle that is negative pi over 4. So one answer that you could give is root 2 negative pi over 4. The negative pi over 4 radial line would be the same radial line as 7 pi over 4, so this would also be another acceptable answer. Root 2, 7 pi over 4. Okay, that point's going to be located in the same spot, and it'd be quadrant 4. Also, now over here, I was choosing r to be a positive. If I were to take r to be a negative, that would be okay. I would just want to make sure that I'm in quadrant 4. Okay, now, if I had -1 over 1 is -1, well, that would be the same as 1 over -1 is -1, right? So if the opposite side is 1 and the adjacent side is -1, that would put me in quadrant 3, and the radial line that we'd be working with there would be 3 pi over 4. Okay, so now I want to be going in the opposite direction because I need to have a point located in quadrant 4. So my answer there would be negative root 2, 3 pi over 4. Okay, any one of these three would be acceptable answers, and of course there's infinitely many answers that you could give. You can make infinitely many revolutions around the pole there. Okay. Now, of course, on an assignment, you don't have to give me, 500 answers. Just give me one. I'm just basically telling you that you got, other options here to consider. So, okay, here's another example. X is negative 1, Y is negative root 3. That point would be in quadrant 3. I also have to make sure that in polar form I'm going to be in quadrant 3. To get R squared equal x squared plus y squared, negative 1 squared plus negative root 3 squared, 1 plus 3 is 4. Take the square root of both sides to get r equal plus or minus 2. If you choose r to be positive, going forward then, okay, let's get theta next. Tan theta is y over x. Negative root 3 over negative 1 is root 3. Now I'd want to look at this as negative over negative though, because if the opposite side is negative root 3 and the adjacent side is negative 1, that's going to put me into quadrant 3, which is where I need to be in quadrant 3 here. And the angle that you would be talking about in that triangle would be 4 pi over 3, right? You'd have a 60-degree angle there in quadrant 3, or 4 pi over 3 radians. So one answer that you could give is 2 4 pi over 3. The 4 pi over 3 radial line would be the same radial line as negative 2 pi over 3, if you were to go clockwise from the pole. So here'd be another answer that you could give. If r was negative 2, then on the pi over 3 axis, if you go in the opposite direction 2 units, that'll put you into quadrant 3. All right, so here'd be another answer that you could give, negative 2 pi over 3. All three of these are acceptable answers, like I said. Okay, now we're going to be doing a lot of this coming up here, where we find a Cartesian equation for a polar equation. We're also going to be working with graphing quite a bit in the next section, but so let's take a look at, here's an equation, a polar equation, r equals sine theta minus cosine theta. All right, let's find a Cartesian equation representing what we see here. So basically, rewrite this equation so that it's in terms of x and y. Well, you want to make sure that you're using your conversion formulas along with some algebra to be able to do that. I'm going from polar form to rectangular form. And so in this equation here, if I begin by multiplying both sides by r, then, okay, r squared, that's the same as x squared plus y squared. R sine theta, that's how we get y, and r cosine theta, that's how we get x. So here'd be my equation now rewritten into a form of x and y. You don't need to solve for x or solve for y, unless you're told to do that. I wouldn't be able to do that here anyway. So go ahead and circle, what we have here. That would be my Cartesian equation. All right, so that's all there is in section 9.1. The homework is on page 584.